श्री गुरुभ्यो नमः। प्राङ्नः व्यनक्तु सगिरं गीर्वाणवन्द्यो रविः। सभायै नमः. Now, in this session, we are going to see the schools and thinkers of Indian astronomy, which is called Jyotish Shastra. Uh, Astronomy, the study of celestial phenomena, has played a major role in all aspects of life in India. Uh, so it was believed that planetary motions, planetary configurations, would affect the human beings, and it is very essential to find the propitious and non-propitious time to perform religious duties, etc. So the graha sthiti, the planetary configuration, has some effect on our life in agriculture, architecture, etc. So what is this Indian astronomy? It is Jyotish Shastra. Jyotimshi graha nakshatrani adhikritya kritam shastram. Jyotimshi. Jyoti means illuminary bodies, heavenly bodies, which are graha and nakshatras. Uh, the Shastra which deals with the positions of all these and the effects of them. Though this astronomy and astrology combined called Jyotish Shastra, so a closer look into the topics dealt in these various texts. So we can see that a large spectrum of topics that include a discussion on ontological status of a theory as well. So which is related to the scientific investigation, etc. So as expected from the ancient civilization, so Indian civilization, it has a long tradition of uh, astronomy. The oldest text which is available today is Vedanga Jyotisha, composed by Lagadha. The time of which is determined as 1400 BCE. So, as in the earlier talks, we have seen the basis of the position of Dhanishta Nakshatra, Shravishta Nakshatra. This has been decided. This time is fixed for that. And in the earliest interest of astronomy, we find that observing equinoxes, solstitious points, and ritual for the ritualistic purposes, and making of luni-solar calendar, Saura and Chandra, uh, Chandramana, and observing the nakshatras, constellations, to guide the motion of moons, sun, and the other planets also. So this verse we have seen in the earlier talk also. Veda hi yajnartham abhipravruttaha kalanupurvya cha vihitascha yajnaha tasmadidam kala vidhana shastram. This is the science which prescribes the determination of time. So it is called kala vidhana shastram. Similar verse, similar statement we find in the text of Bhaskaracharya. His Siddhanta Shromani, he says, Vedas tavat yajna karma pravrittaha yajnah proktas te to kala ashrayena शास्त्रादस्मात् कालबोधो यतस्यात् वेदांगत्वं ज्योतिषस्योक्तमस्मात्. Since the knowledge of time is essential for performing the yajnas, uh, and yajnas are prescribed by Vedas, so the science which prescribes the determination of time is called Vedanga. So the knowledge of Jyotisha is very much essential for understanding Vedas. Uh, so here, as Professor Mahadevan and Professor Ram Subramaniam ji has pointed out, yajna means it is not just oblation in the fire. So it is related to one's own studies, offering reverences to the learned persons, and the feeling towards the fellow human beings. So there are 5 types of yajnas: Brahma yajna, Pitru yajna, Deva yajna, Manushya yajna, and Bhuta yajna. So this is why in Bhagavad Gita Krishna says saha yajnaah praja srishtva purovacha prajapati. You do the yajna, by that uh, so all the fellow beings as well as the devas will be pleased, and it will be beneficial for us also. uh, so for determination of the time, exact time, so what is the means of knowledge here? uh, for the kala nirnaya, so graha ganita is very important. So kala nirnaya graha ganita adhina. So Nilakantha, in his Aryabhatiya Bhashya, he says like this: Anadinidhanam kalam tallingagrahatarakaah natva bhuvancha sarvatra ihanumatasya darshyate. So Anadinidhanam kalam, so which is eternal, time is eternal. So having bowed down that Mahakala and its indicators, the planets and stars, the Tallinga Grahataraka, the Grahas and Nakshatras are the means of knowledge here. So from this we infer the time. Iha anuma tasya darshyate. Anumana, the means of cognition. In his introduction, he says, Tameva kalam jyotirgati visheshaihi anumapayitum kalakriyapadaha arabhyate. This is the commentary on the Kalakriyapada section of the Aryabhatiya. There he says, in order to determine the time through the movements of heavenly bodies, the section Kalakriya is commenced. Astronomy, Indian astronomy has a vast period. So there it can be grouped into three periods majorly: early Siddhanta period, and late Siddhanta or medieval period. So till 400 Common Era, all the previous Siddhantas, so some of them are not available today. In the Siddhanta period, we have Aryabhata Siddhanta, Brahma Siddhanta, etc. And in the medieval period, there are many astronomers, and the Kerala school of astronomy we will be going to see. And when we come to this earlier Siddhantas, according to the tradition, there are 18 Siddhantas. These are the names of 18 the Pravartakas, Jyotish Shastra Pravartakas, the authors of these Siddhantas. Suryaha Pitamaho Vyaso Vasishtotrif Parasharaha Kashyapo Narado Gargo Marichir Munirangiraha Lomashaf Paurishashcheva Chavano Yavano Bhragu Shaunakascha Ashtadashaschaite Jyotish Shastra Pravartakaha. So most of these are not available today. So Kala, the Kala Pravaha, we have lost them. Only 5 of them are available to us today in the form of extracts and summaries. So because of Varaha Mihira, who compiled the Pancha Siddhantika, so these 5 are available to us in the form of summary or the extracts. So why are these not available? Because of their inefficiency in producing the exact results, or the later Siddhantas have finer accuracy. Because of that, earlier Siddhantas were forgotten. That is also possible. So because of the easier methods prescribed by later astronomers, the earlier ones were forgotten. So in the Pancha Siddhantika, we find these sets of verses where Varahamihira says, Paulisha Romaka Vasishtha Saura Paitamahastu Pancha Siddhantaha. These are the Pancha Siddhantas. Panchabhyo Dvavadyo Vyakhyato Latadevena. There was an astronomer called Latadeva who has written commentary on those two. And the tithi computed through Paulisha Siddhanta. Paulisha tithi is Sputaha Asau. It has accuracy, and Tasyasannastu Romaka Proktaha. Romaka Siddhanta is near to the accuracy, and Spashtataraha Savitraha. Savitraha is Saura Siddhanta, Savitra Devata, Saura Siddhanta, and Parisheshu Dura Vibhrashtau. So other two are so far from the accuracy. And he says, so what is the Pratipadya Vastu here? What is the subject matter discussed in these Siddhanta? यत्तत्परं रहस्यं भ्रमति मति यत्र तंत्रकाराणां तदहमपहाय मत्सरमस्मिन् वक्ष्ये ग्रहं भानोः. I shall tell in this work, avoiding all jealousy, the computation of the solar eclipse, which is guarded as a great secret and in which the mind of astronomer reels. दिक्स्थिति विमर्द कर्ण प्रमाण वेला ग्रहाविंदो ताराग्रह संयोगम देशांतर साधनम चास्मिन् सममंडल चंद्रोदय यंत्र छेद्यानि शांकवच्छायाः उपकरणाध्यक्षज्यावलंबकापक्रमाद्यानि. So he lists out all the topics which are discussed in the Siddhantas. The directions of the first and last context in the eclipses, the duration of total phase, the hypotenuse used to compute, and the conjunctions of stars and planets, Tara Graha Sanyoga, and Deshantra Sadhanam, which is the longitudinal difference, shadow measurement, signs of latitude. This is called Akshajya, and Lambajya is co-latitude, declination is Kranti. All these matters are discussed in these texts. Later, in the Siddhanta period, those Siddhantas followed the earlier ones, and they made substantial development in the theories and contents. And these Siddhantas became popular in different parts of the country, where expositions were written on them, and manuals to make the computations easier, so that the Panchanga makers will be able to do easy computations. Tables, instruments, etc. were composed based on these texts. So we see that a very large number of astronomers have worked for the development of this discipline, and these Siddhantas or the texts can be grouped in 4 schools: Arya Paksha, Ardharatrika Paksha, Brahma Paksha, and Saura Paksha. In the Siddhantic astronomy, the leading figure is Aryabhata, who composed his monumental text Aryabhatiya in 499th Common Era. He was born in 476. So when he was very young, he composed this. After the composition of this text, this is the first text available text for us, which deals with completely with astronomy and mathematics, the computational astronomy. So later, the main occupation of the astronomers for the next 1,000 years was about the calculation of geocentric planetary orbits and developing algorithms for the solution of the mathematical equations in this process. And after Aryabhata, we have the astronomers like Latadeva, and who was the pupil disciple of Aryabhata, and Varahamihira, who compiled the Panchasiddhantika, and he was a researcher, and he wrote a text called Brihat Samhita. It is a big volume on omens, etc. Bhaskara, one who wrote a commentary on Aryabhatiya, and Aryabhata's critic Brahmagupta, and Brahmagupta's works were translated into Arabic also, and we have Lalla later, and Munjala, Shripati, Bhaskara, second Bhaskara, who is known as Bhaskaracharya, and these were the celebrated astronomers. And we have great commentators on these texts also: Prutudaka Swamin, Bhattotpala, Parameshwara, who was from Kerala, and so on. This Siddhanta astronomy adopted sophisticated sophisticated mathematics, incorporated the planets in the system, devised a system of coordinates for the determination of the periods of planetary revolutions and the relative sizes of Earth, the Sun, and Moon. And mean longitudes were computed from the number of days that elapsed from the beginning of Kalpa or Mahayuga or Kali Yuga, and the length of the year, etc., were mentioned there. And uh, planetary positions were computed using the epicyclic and eccentric models. Eclipses were also computed with accuracy, and these computations were involving geometrical, arithmetic, and algebraic practices, some aspects of plane and spherical trigonometry, and application of indeterminate equations also. So, the topics discussed in Siddhanta texts are like this. These are called adhikaras. The chapters are called adhikaras, like Madhyamadhikara, Spashtadhikara. In Madhyamadhikara, mean motion of longitudes of the grahas are discussed. How do we find average uh, mean position of the planets? Later, some corrections are applied, like equations of center, and by means of this, we get the true positions of the planets. This is discussed in the Spashta Adhikara. Procedure for computation of the positions of the sun and moon, and computation of this Panchanga, Tithi, Nakshatra, Yoga, Karna, and true longitudes of Mars, Venus, etc. And in the third chapter, Triprashna Adhikara, this deals with the Dik, Desha, and Kala, direction, the place, and time, and shadow measurements, the computations of the longitude, etc., latitude from the shadow measurement, and determining lagna. Lagna is an important concept for finding the muhurta also. So this is lagna is oriental ecliptic point. The point at a given point of time, the which point of the ecliptic rises. For example, at this point, if I want to know what is lagna, I have to compute which part of the ecliptic is rising now. This is an interesting problem, which is discussed in detail in some other texts also. And Chandra Grahana, the eclipse of the moon, Surya Grahana. Here, the text describes how to present it in a graphical way, also graphical representation of the eclipses, and it deals with parallax. And Grahodayastamana, visibility and non-visibility of planets. When the planets are very near to the sun, those are not visible. So during what time of the year they will be visible, whether they will be visible in the early morning or after the sunset, all these things are discussed here. And Chandra Shringonati, determining the elevation of the moon's cusps, and Graha Yuddha Samagama, conjunctions of planets. These are the main topics discussed in Siddhanta texts. Coming to Aryabhata, his monumental work was Aryabhatiya, which is an important work in the history of Indian mathematics and astronomy. And this is the text, earliest text which is available today in the which deals with the planetary computations. This is widely accepted. This system is widely accepted throughout India, and we can see that a large number of expositions and commentaries are written on this text. And because of this, Aryabhata school of astronomy and mathematics, this is called Aryabhata Paksha. And based on the Aryabhata Siddhanta, many Karana texts were composed. Karana texts are those texts which which aids the astronomers to compute the positions of the planets using some tables, etc. So Yes, Aryabhatta is an important figure in the history of astronomy. And as we have seen earlier, it contains four sections: Geetika, Ganita, Kalakriya, and Gola. So the Geetika deals with the astronomical parameters and sign table, and Ganita about geometry and arithmetic. And Kalakriya discusses divisions of time, rules for computing longitudes of planets using epicycle model and eccentric model. And Gola discusses with the sphere and problems related to eclipses, etc. And in total, it has 121 stanzas, and this is a text which is marked with brevity and conciseness. uh, this is a kind of sutra kind of composition, or it is very difficult to understand. Just by from the verse we cannot understand many things. We need commentaries on that. Those who are in that tradition, they have elaborated upon them. And so we can see these many commentators who have written commentary on Aryabhatiya: Prabhakara, Latadeva, Panduranga Swami, and Bhaskara first, who was from Vallabhi, and Someshwara, Suryadeva, Parameshwara, Yellaya, Nilakantha Somayaji, Raghunath Raja, Madhava, Bhuti Vishnu, Ghatigopa, Kodandarama, and Virupaksha. And what is the role of a commentary here? Original texts such as Aryabhatiya present the topics in very concise and terse manner, and it is very tough to comprehend the topics discussed there. So the commentary is set for the comprehensive exposition of the contents and thereby provide great stimulus to the study of the original text. These commentators tell the importance of rules presented in the original text and the utility of them. And various discussions not only provide a simple way to arrive at the result discussed in the primary text, but also explain the multiple models about convincing those arguments. And so Nilakantha's Aryabhatiya Bhashya is one of the major commentary available today to us. And there are in this commentary, so we can find several proofs which are very useful in terms of pedagogy. So do it yourself kind of proofs we can find here, uh, which is very important in mathematics education. Uh, these are some works based on Aryabhatiya. So in the Aryapaksha, so the Aryabhata school of astronomy, so those who came in that tradition, they wrote commentaries on Aryabhata, and they composed independent texts also. One of them is Mahabhaskariya by Bhaskara first, and he wrote another text called Laghu Bhaskariya. And there is a commentary on Mahabhaskariya by Govinda Swami and Parameshwara, Suryadeva Yajva. Uh, and there is another Paksha called Ardharatrika Paksha, where this school chose the epoch at sunrise at Lanka, the commencement of Kali Yuga in 3102 BC. The Arya Siddhanta, another work of Aryabhata, was based on this Ardharatrika Paksha. The Aryabhata Siddhanta was based on the sunrise. This is based on the midnight. This Arya Siddhanta is not available to now, but it is known through some of the quotations found in other texts. So who followed this Aryabhatan school? Later, Paulisha Siddhanta adopts the parameters of Ardharatrika Paksha, and Shishyadhi Vriddhita Tantra of Lalla, he follows this Ardharatrika Paksha, and later Surya Siddhanta, which is available to us today, that is also based on this Ardharatrika Paksha, Vateshwara Siddhanta of Vateshwara, and Siddhanta Darpana of Nilakanta Somyaji. And as said earlier, Varahamihira was the compiler of these 5 Siddhantas. He compiled 5 Siddhantas, and it is available to us today as Pancha Siddhantika. This work gives various different relations among the functions jya, kotijya, sine, cosine, and versine, utkramadjya, and it gives a jya table also. Brahmasputa Siddhanta of Brahmagupta, who was in 6th century, it contains 1008 verses divided into 24 chapters. It exerted a great influence on the astronomical thoughts of Western and modern India. Here, Brahmapaksha criticizes Aryapaksha. He criticized the views of his predecessors, including Aryabhata, Pradyumna, Latadeva, Varahamihira, Vijayanandin, Vishnuchandra, Sri Shena, and the Jaina works. There are 2 chapters on mathematics, Ganitadhyaya and Kuttakadhyaya. And in the 22nd chapter, we find various astronomical instruments listed. And Prudhutaka Swami wrote a erudite commentary on it. He quotes an earlier commentary by Balabhadra. Other commentators are Amaraja, Bhattotpala, Lalla, Someshwara, Sridatta, and Varuna. And this work was translated into Arabic under the title Al-Jiz Al-Sindh Hind in 771 by Muhammad ibn Ibrahim. He lived in the reign of Vyagramukha, as seen from his own verse. When he was 30 years old, he wrote Brahmasputa Siddhanta. Here he says, Shri Chapavamshatilake Shri Vyagramukhe Nrupesha Kanrupanam Panchashat Sanyuktair Varshashataihi Panchabhiratitaihi Brahma Sputa Siddhantah Sajjana Ganitajna Golavat Prityaihi Golavit Prityaihi Trimshadvarshena Kruto Jishnu Sutta Brahmaguptena. Here he mentions his father's name, Jishnu. He was a resident of Gujarat, and his work, a Karana work named Khandakhadyaka, is well known. It was written in Shaka 587. It was composed when he was 67 years old. And the length of year adopted by Siddhanta, is 365 days, 15 Gatikas, 30 Pala, 22 Vipala, and 30 Prativipala. This is less than any other Siddhanta except Polish and Romaka. And he discussed with about this tropical sign of actual Sankramana. Earlier, this sidereal Sankramana were discussed, and from his statement, his spirit as a scientist and the pride can be seen in this verse. Brahmokta madhyaravisashita taduccha tatparidhibhi sputikaranam kutvaivam spashta tithi dura bhrashtanya tantroktaihi aryabhatasya ajnanan madhyama mandocha shighra paridhinam naspashta bhumadhyah spashta brahmokta madhyochaihi. Here he criticizes Aryabhata, saying, if you follow the Aryabhata's computational method, you will not get the correct result. So if you follow this Brahmasputa Siddhanta, that will be the Spashta, the accuracy will be better. And see, Bhaskara praises Brahmagupta as Ganaka Chakra Chudamani. Kriti Jayati Jishnujaha Ganaka Chakra Chudamani. Jishnujaha is son of Jishnu. Ganaka Chakra Chudamani. He is the shining among the astronomers. He has been exclaimed as uh, a great discoverer of correct positions of the and motions of planets, and a very intelligent author of scientific works. Uh, in another place, he remarks, when after a long lapse of time, a great deal of discrepancy will be caused, men of genius possessing the ability of Brahmagupta will come to birth, and studying the planetary motions evolved by Brahmagupta will compile work on these sciences. So, by this, what we can understand is, so as time passes, there is a need to revise the Siddhantas, and we have to come up with the precise computational methods. And Lalla, the author of Shishyadhi Vriddhita Tantra. Shishyadhi Vriddhita Tantra, what does it mean? That the Tantra which enhances the uh, intellect of students. Shishyadhi Vriddhi, the Tantra. So he belonged to Aryabhatan school. Aryabhata Vidhana Siddhanta Tulya Phalamakari Tantram. So he says, I have compiled a Tantra which yields the results equal to the Aryabhata Siddhanta. And he wrote some other works also which are not available today, work on arithmetic and muhurta. There is another Aryabhata. There was another Aryabhata in Shaka 875. He wrote a text called Mahasiddhanta. It has arithmetic chapter on arithmetic also. It contains 625 couplets. In 13 chapters, he deals with astronomical computations, and in the 14th chapter, he deals with celestial sphere, and 15th chapter deals with the Pati Ganita, arithmetic, and 16th chapter is about Bhuvana Kosha, the universe, and theory of mean planets discussed in 17th, and algebra, Kottaka problems in the 18th chapter. And he employed a Katapayadi system, which is and we have several commentators in this tradition. Govinda Swami, Prithudaka Swami, Skanda Sena. Prithudaka Swami wrote a commentary on Brahmasputa Siddhanta, and Skanda Sena, uh, who gave geometrical interpretation for arithmetic series, and Bhattotpala is a commentator on Khandakadhyaka of Brahmagupta. He was from Kashmir. Now, coming to the ontology of a theory. So, how whether a scientific theory and the theoretical entities associated with it should reflect the physical reality or not. This has been a matter of debate in the scientific field. Of it has been discussed by various philosophers and all civilizations. Indian tradition seems to have nurtured the theoretical entities. They can be true or false, but it should lead to the right knowledge. Since Vedic times, this has been followed. Uh, the societies which did not succumb to the idea of the theory and theoretical entities should mirror reality and conceive them merely as convenient tools employed to explain a given phenomenon, had no serious issues in accepting an alternative hypothesis. The societies which believed only in the theoretical entities should be real, they had many problems. They, um, uh, in Western countries, we could see that, and uh, any theory or model that was acceptable as long as it could serve the purpose of providing a satisfactory explanation for the observed phenomenon. Uh, the scientists in those societies did not have to face serious problems in expressing their views freely and fearlessly. We will see some of the examples also. This see in the role of intellectual freedom in its germination. It is well known that there is a close correlation between the intellectual freedom and evolution of ideas, with the latter heavily dependent upon the former. Hence, it is becomes the moral responsibility of a society to provide conducive environment for the scientists to express their views freely without a sense of fear. Uh, by the word free, what do we mean? So it is the absolute freedom is impossible. Uh, it is free from the prejudices and propaganda. That much we can say. Uh, this, of course, this only a necessary condition, not sufficient one. In fact, a scientific community would be deemed ethical if and only if it encourages the individual scientists to come up with new hypotheses, however conflicting it may be, or challenging the notions of the established scholarship. Uh, so, hypothesis is an informed guess or the tentative conjecture about a theory, and theory is a well substantiated explanation offered with respect to any phenomenon. Uh, what are the theoretical entities? The tools that are introduced in the process of building a new theory is called theoretical entity. For example, the epicycle, the deferent circle, is called Kakshavritta, Graha Brahmana Vritta, and Manda Paridhi, etc. These are theoretical entities. Similarly, in Vedanta, we have Maya, Avidya, etc. So these are just theoretical entities employed in the Advaita Vedanta. And these theoretical entities play a decisive role in our understanding of the physical phenomenon. What is the truth about these theoretical entities? Should they be considered real or non-real? This is the question. So with an example, let us see this. So in the earlier session also we were discussing about the revolution of the earth, etc. Here we will discuss about the rotation of the earth. All of us observe that periodical rising of the planets and stars and the stellar objects. There are two possible ways of explaining this. We see that stars are rising and setting, sun is rising and setting. How can we explain this phenomenon? Either we have to say the earth spins around its axis once a day and thereby causes the apparent motion of the sun, etc. Or you have to say the entire celestial sphere with all objects is moving towards west. All sky itself is rotating. So the two views are possible here. So what was the belief held by Greeks here in this astronomy? They had 27 spheres for various planets, and in this process they consider earth was not only considered to be at the center of all these shells but also totally immobile and reference point of all perceived motions. By the time of Ptolemy, the views had acquired fairly sophisticated mathematical foundation, and they found a solid ground which sustained them for about 1400 years till the time of Copernicus. See, in this Greek model, they had 27 spheres, 3 each for Sun and Moon, and 4 for each Mercury, Venus, Mars, Jupiter, and Saturn. And the final sphere carried all the fixed stars. Uh, it contains the whole universe. Each sphere turned on an axis at a uniform rate of speed and was attached to adjacent spheres in its axis. What was the Aryabhata's view? He says, Anuloma gatirnaustaha pashyatyachalam vilomagancha yadvat achalani bhani tadvat shama paschimagani lankayam. Just as a person in the boat moving in the forward direction observes the stationary object trees on the bank to be moving in the opposite direction, as we also experienced while moving in the vehicle. So also the stationary stars seem to move directly westward for an observer in Lanka. Lanka is a reference point. So as per this picture conveyed by this verse, the rotation of the earth is real, and whereas the motion of the celestial objects is only apparent. This of course is a very bold hypothesis by Aryabhata, whereas all the other astronomers were saying Prithvi is achala, so it is static, it is stationary, and all other things are moving. He was bold enough to put forth his hypothesis when any empirical evidence is absent. And in the very next verse, he says, Udayastamaya nimittam, it is a quite, it is opposite view, the second view. Udayastamaya nimittam nityam pravahena vayuna kshiptah lanka samapashchimagah bhavanjaras sagraho bhramati. For the sake of rising and setting, being blown by the pravaha wind, the stellar sphere along with the planets move westward in the uniform rate. Here Aryabhatta seems to have provided the completely opposite picture. Uh, that means the rotation of the stellar sphere. Is he justified by giving two opposite views? Let us see that. See, the Nilakanta Somayaji in his work, he reconciliates these two views. Aryabhatta in his beginning chapter, he says prane naiti kalambhu. The earth rotates 1 arc minute in 4 seconds, and he says there, and he just says the rotation of the earth here. And Nilakantha, while discussing these things, he says Kshitehe kakheshu gogunashtashyagnyashvidvyashta sharendavaha. See, this is a big number, the number of rotations of the earth in a kalpa. So, see, this is given in the Bhuta Sankhya system. Kha kha ishu go guna ashta ashwa agni ashvi dvi ashta shara indava. See, this is a beautiful way of representing numbers so that they can fit the number in the chandas. So if he has to say ekam dve trini etc., so those words may not fit in the meter of a verse. So he has used the word numerals. Kham means 0. Kham means sky. It represents 0. Ishu means bana, the arrow. It represents 5. And Gau represents 9. Guna represents 3. Ashwa denotes 7. Agni for 3. Ashvi 2. Dvi, of course, 2. Ashta 8. Shara is again 5 arrows. And Indu is moon 1. And it is written from the other way, left to right we have to read. So that is how we have this number 158223 etc. Here he says, Nilakantha observes that Kshitehe kalpe prag brahmana sankhya bhanam kshitya prekshya pratyak brahmana sankhya. The number of rotations of the earth in a kalpa towards east is equal to the number of rotations of the stars towards the west. So either earth rotates or the stellar sphere rotates, the number remains same. Both the ways there is no distinction in the planetary calculations. So there is no harm in either way. So in the absence of a foolproof empirical evidence that is acceptable among the peers, it may not be possible to provide an edge over the other. So Aryabhatta, being an outstanding scientist of his own class, might have sought for a much simpler and elegant model than the prevailing one. So so when we come to the simplicity and elegance of in a scientific statement, the scientists, particularly the historians of science, they search for the simplicity and elegance in the. They feel that it plays a major role in the advancement of science. This has been well acknowledged by the historians also. For example, Richard Feynman, in his 6 easy pieces, he says this. And in fact, P.M. Dirac, a renowned theoretical physicist and one of the founding fathers of the quantum theory, he says that it is more important to have a beauty in one's equation than to have them fit experiment. This is a powerful and emphatic statement, and so it helps in the advancement of science and technology also. So perhaps Aryabhatta tried to have some simplicity in the hypothesis and theory. That is why he has proposed the alternate view. And regarding the correctness of a model, in the scientific arena, questions regarding the correctness of a model are generally decided by looking upon which of the model leads to the more reliable results and predictions. If the power of prediction is equivalent, then which of them is simpler and more consistent with the other bodies of knowledge systems? Given the tools available in those days, it would not have been possible for Aryabhatta to give more weightage for one model than the other without unwarranted and unjustified assumptions. That he did not do so is itself the evidence of the fact that he has stood with the principles of ethics and practice of science. That is what we have to understand from this contradictory statement or opposite views. And see, Aryabhatta has proposed this theory, or he has put forth his hypothesis of rotation of Earth. But what happened later? The theory of rotation of Earth was not acceptable to many of the astronomers in the later period. Brilliant mathematicians and astronomers like Brahmagupta, Lalla, the Bhaskaracharya were quite skeptical about this theory and have strongly refuted it in their own works. But these refutations were objective and solely based on sound logical reasoning and not on the belief of faith on some established order or due to fear of the violation of the authority. So some people say that it is because of the orthodoxy they have criticized Aryabhatta. It is not like that. They had some logic in refuting the views of the earlier astronomers. So it was a purely scientific way of criticizing. So in Brahmasputa Siddhanta, he has dedicated an entire chapter, Tantra Pariksha, for criticizing the earlier astronomers. So to examine the correctness of different schools of astronomy prevailing during his times, Brahmagupta. And most of the verses in this chapter are noted to be pointing towards Aryabhatta. Why? Because Aryabhatta was a noted astronomer, brilliant astronomer. His theories were studied by many. So he felt that I have to criticize him in order to establish my viewpoint. So the most popular school will be criticized by the later ones. After pointing out the inaccuracies in some of the parameters and theoretical entities employed by Aryabhattan system, Brahmagupta refutes the theory of rotation of Earth. He says, Pranenaiti kalambhuh. This is the word of Aryabhatta. Pranenaiti kalambhuh yadi. Tarhi kuto vrajet kumadvanam. If Earth rotates like this, then, so he talks about the birds. Avartana murvyaschenna patanti samuthraya kasmat. If the earth were to be spinning at the rate of 1 minute in 4 seconds, then what were and why would they birds live? Further, if the earth were to be rotating, then why is it that the tall rises like places of mountains do not suffer a fall? So, because earth has to complete one entire rotation. So it is a tremendous speed. By this, all the human beings will fall or all the objects will fall. If the earth was rotating at a tremendous speed, then how would the birds, which having left their nest or trees, be able to reach back their own homes during the sunset? This is one of the standard objections raised by many astronomers. So actually no satisfactory answer was available for these objections till the time of Newton also. So this the conception of whole troposphere is spinning with the earth, that was not known then. Though the Copernicus tried to answer these objections the following way: these bodies being terrestrial and consequently sharing the nature of the earth, share also the natural motion of rotation which coexist in them together and their own proper motion. So it can be easily seen that the above explanation is based on the revised or slightly modified set of beliefs. The Shripati, a 10th century astronomer, in his Siddhanta Shekhara criticizes this view as by saying, He gives the graphic description of the events and mishappenings that may take place if the earth were to rotate in a tremendous speed. Yadyevamambaracharaga vihaga swanidam asadayanti nakalu brahmane dharitryaha. If it were so, if the earth were rotating, the birds which fly to the sky may not be able to return to their nests on account of rotation of the earth. Kinchambuda apina bhuri payomuchasyuh deshasya purvagamanena chiraya hanta. The clouds may not be able to incessantly pour at a particular location of the earth, as the location over which they were residing would have long back shifted towards the east. In this way, the later astronomers were saying that tasmad bhramatyudugana swachala achalaiva. The achala means achala is the synonym of earth. So that is why achala is achala. That means earth is stationary. It can be observed that any criticism of the theory of rotation of the is purely based upon logical reasoning and not some obfuscate faith. A person with good understanding of the fundamentals of physics today may be tempted to deride the arguments presented above and declare that these arguments are totally baseless. However, one cannot deny the fact that they are based upon close examination of certain phenomena and application of induction and deduction with whatever knowledge is available to them. But what misunderstanding prevails in the scholarly field regarding the criticism of Aryabhatta by Brahmagupta? So we have seen how they have refuting the theory hypothesis with logic, but the modern scholarship is unfortunately of the opinion that Brahmagupta played up the religious orthodoxy by criticizing Aryabhatta. This is completely a misconceived notion. Perhaps the misconception and reproachful language used to refer to Brahmagupta are based on misjudgment, which in turn can be ultimately traced to Al-Biruni's works. So, such criticism came from the we have seen in the Amartya Sen's novel, right? Amartya Sen's book. He quotes Al-Biruni. See, this is what happens when you don't have access to the source text. So Al-Biruni has written something and somebody else is quoting him. It is possible that facts presented and misunderstood due to misreadings and lack of scholarship in the original texts, which are written in technical Sanskrit language. Yes, in the work Argumentative Indian, this kind of criticism we see. While Brahmagupta deserves to be praised for his courage and uprightness in expressing his views soundly and clearly in a separate chapter based on his own convictions against the well-established Aryabhatan school, but he has been abused now. Again, it should be noted that Brahmagupta challenged Aryabhata's views purely on the basis of his own experimental and observational results with perfect logical reasoning, which he has imbibed as a great mathematician and not based on the religious scriptures or orthodoxy. He says in his Tantra Parikshadhyaya, Shrishena Vishnu Chandra Pradyumnarya Bhatalata Simhanam Grahanadi Visamvadat Pratidivasam Diguna Majnatvam Yuktya Arya Bhatoktani Pratyekam Dushanani Yojyani. Based on logical analysis, Yuktya, the word he uses, the word Yuktya is very important here. In the Aryabhatan system should be extended of each of the other systems. Based on Yukti, he has refuted the other views. Yukti means the logical reasoning. This has to be noted. Nowhere he says that because of the religious belief I am refuting Aryabhata, or because this scripture says so, I am supporting that. In such way, he doesn't defend. With logical reasoning, he refutes. That is the Tantra Parikshadhyaya, examination of the correctness of other views. It may be hard to find instances of astronomers crossing the borders of ethical boundaries employed in the practice of science, either in the process of supporting or in the process of refuting of the theory in favor of the other. So while coming to the the, the realism and versus anti-realism debate about these theoretical entities, as far as the Indian tradition goes, all the astronomers seem to have uniformly accepted the epistemological principle that there indeed be no constraints imposed on the theoretical models of the procedures as long as the prayojana of the purpose or the purpose of the Jyotisha is achieved. So, what is the purpose of Jyotisha? So, as said earlier, it is Kalabodha. Shauta Kala Parichedah Shastrasyasa Priyojam. The purpose of this Shastra is to know the exact division of time for the performance of the different actions. And the purpose of Shastra, the Indian astronomers had a clear understanding that the science is essentially human construct. It is called Purusha Buddhi Prabhava. And as a human construct, there are bound to be differences of perception. And Indian scientists learn to reconcile and live with the different viewpoints. The classical example, what we have seen, the rotation of Earth or the stellar objects. So these astronomers did not put any constraints on the theoretical entities as long as it had theoretical utility. Yes, Bhaskara 1. So he explains how the Indian epistemological view that astronomical models and theories are upayas, and cites the Vakya of Bhartrahari in this. Athava sphuta grahagatiraatra sadhyate. Here we are going to determine the true positions of the planet. Tasyaha sadhanopayaha, the means of achieving them. Madhyamaha, Shigraha, Mandaha, Paridayaha, Jya ityadi. These are all theoretical entities utilized in the astronomical computations. Sacha sphuta grahagatihi etaihi upayaha sadhayitum shakyate nanyatha. Without these upayas, techniques, we cannot achieve the result. यथा प्रकृति प्रत्यय लोपागम वर्ण विकारादिभिः उपायैः साधु शब्दः साध्यते एवं अत्रापि तस्माद् उपायाः उपेय साधक. In grammar we have suffixes, prefixes, prakriti pratyaya, etc. So in order to prove the some word as a correct word, so those are just upayas. Tesham na niyamah. There is no constraint in this. Uktancha upadaya piyeheyaha tanupayan prachakshate upayanancha niyamo navashyamavatishthate. So in Vakya, so upayanam cha niyamaha na avatishthate. So you can utilize the upaya and leave it later. So you need not stick into that upaya. Etaihi upayaihi. Upayaihi, yes. Upayaihi sadhayitum shakyate. And avatishthate. Avatishthate. Tasmad upaya matratvat na doshaha. So this is the epicyclic model we see in the computation of the true planet. See here, that blue circle is called Kaksha Mandala, deferent circle, and the P naught, it is the position of mean planet, the average position of the planet, mean position of the planet. The small circle is called epicycle. So now say U is the direction of apogee, OU is the direction of apogee. So parallel to that we draw a line P naught P. So P is the position of the true position of the planet is P. So now we have to apply correction, this PO P naught, that angle is the correction. So for finding this correction we are using this model. This epicycle, so we don't have such a sphere or sphere in the sky. Just it is a model we are using to compute the position of the planet. In reality, it doesn't exist. So this Ucha, Nicha, Madhyama Paridhi, Ityevamadi Sputagati Sadhanopaya Bhutanam Chopayanam Naiva Niyamoktirva Vidyate. So these are just theoretical entities. Kevalam tu upeya sadhaka upaya. These are only the means for arriving at the desired results. Hence, this entire procedure is fictitious by means of which the observed planetary motion is arrived at. And he gives some other examples how this the establishment of truth happens. Evam cha paramartha jijnasubhi asatyopayena satyam pratipadyate. Ultimate truth is established through untrue means. Tathahi, he gives example, Bhishajaha Hyutpala Naladishu Vedadhinyabhyasyante. Just as the surgeons practice their surgery on the stems and other objects. Napitaha Pitharadishu Mundanadini. Just as the hairstylists practice shaving on pot. Yajna Shastravidaha Shushkeshtya Yajnadini. Just as the experts in the theory of Yajna practice its performance by means of dummy sacrifice Shushka Ishti. शाब्दिकाः प्रकृति प्रत्यय विकारागम वर्णलोपव्यत्ययादिभिः शब्दादीन् प्रतिजानते. Just as the linguists utilize notions such as prakriti, pratyaya, vikara, agrama, varna, lopa, vyatyaya, etc. to comprehend the words. In the same way, in our science also, the astronomers employ notions such as madhyama mandocha, shigrocha, shigraparidhi, jya, kashtha, bhuja, koti, karna, etc. These are all just in order to comprehend the observed motion of planets. Hence, there is indeed nothing unusual that fictitious means are employed to arrive at the true state of affairs. So, thus, in the Indian context, any number of hypotheses can be put forward as long as they can explain the observed phenomenon. The question of truth of or falsity of the hypothesis never rises. In other words, the issue regarding the reality of the models was not of much relevance because models themselves were simply viewed as conceptual tools. So, in short, both true leads to true and false leads to true were acceptable in the empirical level. While the tools may play an important role in the description and understanding of the reality, they need not be real themselves. This was the stand of Indian astronomers. And not only astronomers, various philosophers also said like this. For instance, Sureshwaracharya, one of the earliest acharyas in the Vedantic tradition, says, Yaya yaya bhavet pumsam vyutpattihi pratyagatmani sasaiva prakriyajneya sadvi sacha anavasthita. Any theoretical model that helps in a person to understand the nature of inner self has to be considered valid. And there is no restraints on the number of such models. In the Appaya Dikshita in Siddhanta Sangraha, he says, Prachinair Vyavahara Siddha Vishayeshu Atmaikya Siddhau Param Sannakyadbir Anadarathranayo Nana Vidha Darshitaha. With the understanding that too much of importance need not be given to the theoretical constructs as long as the primary purpose of recognizing the oneness of the self is achieved, different models had been proposed by the ancients. And another commentator, Achyuta Krishnananda Tirtha, he says, Vivakshita vastu pratipatyupayataya viruddhanana prakara pradarshanam acharyanam na doshaya bhavati kintu alankaraya eva. As a tool for understanding the idea to be conveyed, there is nothing wrong in different acharyas proposing different theoretical models that could even be in contradiction to each other. In fact, it is only an ornament. Coming to the astronomical tradition, we find in the Kerala. So this discipline has extremely flourished in the current state of Kerala that has produced reputed astronomers. Legendary Vararuchi, who was in 4th century AD, was the author of Chandravakyas, which Acharya has stated in the previous session. And Haridatta, who was one of the leading figures in the conceptualization of and dissemination of the Parahita system of astronomy, his texts are called Mahamarga Nibandhana and Grahachara Nibandhana. And we have Govinda Swamin, Shankara Narayana, Udaya Divakara, and so on. And now we identify the Kerala School of Astronomy of Mathematics as the medieval period, which started with Madhava, who was in 14th century. He was well known for his contribution to mathematics, in particular to the branch of mathematical analysis. He gave the infinite series for pi, the sine, cosine functions, as well as the fast convergent approximations. Also, he made significant contribution to the advancement of astronomy. And Parameshwara, who the proponent of the Triganita system, and he made a careful study of observations of eclipses. These are different names we find in this tradition: Parameshwara, Damodara, Nilakanta Somayaji, Chitrabhanu, Shankara Warrior, Jeshtadeva, Achyuta Pisharati, and this tradition continues up to 19th century. Madhava, in his Lagna Prakarana, he discusses various methods to determine the Lagna, the Orient ecliptic point, the computation of Lagna. There, so one of the examples I can show this regarding the computation of Prana Kalantara, where this formula is given: Antyadjujiva hatabahu jivam ishtadjumurvya vibhajedavaptam chapikritam bahu gunasya chapat vishodhitam prana kalantaram syat. See here, all these are technical terms. Antyadjujiva, hata means multiplied, bahu jiva, ishtadjumaurya. See, when we convert it into the modern notation, see, lambda minus alpha is so like this we can show in the modern thing. So let me explain a little bit that. So here in this figure, in this diagram, we have P is the pole, north pole, and K is the pole of the ecliptic. Pole of the ecliptic means which is ecliptic is the sun's path, so which is 90-degree away from that. See here, ecliptic is marked with the red color, and equator is also marked. Here, gamma, the intersection of ecliptic and equator, is the vernal equinox, marked with gamma. This lambda is the longitude of the sun. So let S be sun, the sun. So lambda is the longitude of the sun, and alpha is the right ascension. How do we get alpha? By drawing vertical from P, northern north pole, through the sun, then it touches the equator at B. So gamma B is called right ascension. So the difference between this lambda and alpha, this is called prana kalantara. So this is a very essential in the computation of lagna. So here epsilon is the obliquity of ecliptic, which is also the maximum possible declination of the sun. Delta here is the declination of the sun, how far the sun is from the equator. So this is called kranti. So antyadjujiva hata, antyadjujiva means cos epsilon, and cos delta is kranti kotijya. Sin lambda is bahujiva. So when chapa means the sine inverse of that. So this is how we get. So using the spherical triangle we get it. Here we have to consider the triangle P gamma S. Then applying the sine rule for spherical trigonometry, we get the expression for alpha. The same thing when we supply r, radius, into that, we get this expression. So in Indian sine, jya is r sine of an angle, is called jya, r sine lambda. This is called bahu jiva. is called the jya of the longitude. So here R sign means jya. The sign, the modern sign multiplied by the radius, it gives the jya. So this is how the Pranakalantra is computed. This is based on the spherical trigonometry. So such many formulae we can find in the work Lagna Prakarana. So it is various methods of computations here. Madhava is known as Golavit, the knower of the sphere, the celestial sphere. He was praised like that. So looking by careful look at this work, we understand why he was called Golavit. So later Nilakanta Somayaji, in the same tradition, he was in 15th century. So all his details were given in his own text. He was called as Gola Chudamani and Shaddarshani Parangata. He knew many subjects apart from the astronomy. He was the knower of Vyakarana, Mimamsa, etc. He contributed as a researcher, scientist, mentor, commentator, expositor. So we have a great contribution of him in this tradition. These are some of the names of his texts: Tantra Sangraha, Golasara. So some are in poetry, some are in prose. Chandrachaya Ganitam, Siddhanta Darpanam, Jyotirmimamsa, Aryabhatiya Bhashyam. These are there are some other works also. See, Nilakantha emphasizes on rationales and demonstrations. See, he says in his Aryabhatiya Bhashya, Rashyor Yoga Tadantarena Gunitah Tayor Vargantaram. The multiplication of the sum of the two numbers with their difference would be equal to the difference of their squares. Is a plus b into a minus b is equal to a square minus b square. That. So you have to supply logic for this. Yuktischa ubhayatha pradarshya. Ganana nyaya matrena kshetra kalpanaya cha. It has to be demonstrated with arithmetic rules as well as with geometric constructions. Similarly, he says while explaining the Q, Tadyuktirapi mridadina pradarshya. It has to be demonstrated by means of clay models, etc. After explaining the Ghanasya Yuktihi, the Pradarshita, he says, Eshaiva Kshetra Kalpanayapi Pradarshya. This has to be demonstrated by the geometrical depiction. Here, while discussing the precision of equinoxes, etc., he says, Bhagola, this is in the previous session itself we have seen. So the ecliptic and the celestial equator, where on the ecliptic we have seen Mesha, Vrishabha, etc. So here he says, Bhagola Madhyavrittardhe Vayugolasya Madhyatah Apakrante Chaturvimshati Saumyeta Rashyo. He says how the obliquity of the ecliptic towards equator. Here the modern the value is 23 degree 26, but in the earlier times it was taken as Chaturvimshati 24. And he says, see here the intersection is marked as gamma. So he says this point of intersection is not constant. Tatra bhagolavayavanaam vayugola avayavaihi saha sambandho nirniyataha. So in this context, so we can remember the verse of Varahamihira also. So Ashleshardha Dakshinam Uttaramayanam Raver Dhanishtadyam Nunam Kadachitasit Yenoktam Purva Shastrishu. Varahamihira says there was indeed a time when the sun's southerly course, this Dakshinayana and Uttarayana, began from the middle star of Ashlesha and Uttarayana from Dhanishta. This is what we find from earlier works. But at the time of Varahamihira, it got changed. Some precision has happened, and now it has come westward. Bhaskara also notes this, and Nilakantha also notes this. So here, Bhaskara, first Bhaskara says, Yam asmakam smriti pratyaksha avyabhicharini. So we call the Jyotisha Shastra as Pratyaksha. So anything we compute, it should coincide with the observation or whatever see in the sky. So Pratyaksha Avyabhicharini. So it should not deviate from the Pratyaksha. So he says how during the Makara Sankramana and Karkata Sankramana, the length of shadow, etc. He explains about this, and he says because of this we have to understand there is a precession of equinox. And this is just about the Sauramana and Chandramana. So Sauramana is solar calendar where Suryasya Gatya Sauramanam. The movement of sun or the transit of sun from one Rashi to another is called Sankramana. From this we have Mesha, Vrishabha, Mithuna. These are 12 Rashis and 12 Sankramanas we have. These are called solar months. The duration for which in which sun resides in one Rashi is called solar month. So we have Mesha, Vrishabha, Mithuna, etc. So these are just the information about the Rutus, 6 seasons, and so as we have seen earlier, the lunar method of computation. Amantad amantam hi chandro hi masa. From Amavasya to Amavasya, we have lunar month. Those are named as Chaitra, Vaishakha, etc. And we have 2 Pakshas, Shukla and Krishna. These are bright half and dark half, and Tithis, Pratipadvitiya, etc. Just I will skip this. This is the Nakshatra Chakram. We can see that Ashwini, Bharani, Kritika, Rohini, Mrigashira. See, these are the, what does Ashwini Nakshatra means? It is the 127th part of the circle. The ecliptic is called Ashwini. So if we take the circle as 360 degrees, divided by 27 gives 13 degree 20 minutes. Moon stays in that particular portion of the Rashi for a day, for lesser than day, 0.98 day, you can say. So the each nakshatra, we have daily nakshatras. Aaj ka nakshatra kya hai? Means where the sun is. Sun is in which nakshatra. So based on that, we have to say which Rashi it is today. So now 27 nakshatras are grouped into 12 Rashis. So in each Rashi we have 2 and quarter nakshatra. So Ashwini, Bharani, Kritika, Padaha, Meshaha. Ashwini nakshatra, Bharani nakshatra, and quarter of Kritika nakshatra make Mesha Rashi. And another 30 degree 20 minutes make Vrishabha Rashi. Like this. So this is how our Janma Rashi is decided. Based on our nakshatra and the pada of the nakshatra. Now, we said from the Ashwini nakshatra, this Mesha Rashi starts. But what happens? So this the conjunction of this ecliptic equator, which is called vernal equinox, that goes westward, or moves westward. Bhamshaish chalati tadyoga prak praticho pratak pratak. In Indian tradition, it is considered that that point of intersection oscillates. It goes 27 degree back, comes to the same position, and 27 degrees forward and comes back. So this is how it was understood here. And it is the rate of motion is for 54 seconds. So that is what Nilakantha said in his work. Here the relation of the parts of the ecliptic with the parts of the equator is not invariable. Choosing a particular point on the equator and mapping it on the ecliptic at a given point t0, if one tries to map the same point of the equator on the ecliptic at a later point t0 plus t, it would be noted that the mapping is not invariant. So this is how did they know this? Through observation. And see here, this R1, R2, R3, etc. These are the ending point of the Rashi. R1 is first Rashi, the ending of Mesha, ending of Rishabha, ending of Mithuna, like that. So here we can see, so Mesha Rashi has started in R0. R0 is the Mesha Adi. But actually, this point of intersection should have been at R0. At a point of time it was, but now it has moved further, eastward shift. So earlier it was like that. So now, so the astronomers compute the declination of C. C is the Chitra star, Chitra Nakshatra. They have observed that this is the maximum declination it can have, the deviation from the ecliptic. So when it moved eastward, it happens like this. It moved westward, it happened like this. So such kind of observations and the data available to them made them to decide that there was a precession of equinox. So and here, so he describes all these things, and in Siddhanta Darpana we see this. He has listed out some conjunctions of stars and planets. So he says author cites some of the star planet conjunctions observed in his time. In 1491, he saw the moon covering the star Chitra. In 1493, Mercury was observed towards the north of the Chitra, and he has noted all the observations. And by this, he has concluded this. And he gives some reasoning for the precision of equinox. Coming to the geometrical picture of planetary motion, see, this is how they have conceived the picture of geometrical picture of planetary motion. Here he says, so this is the remarkable contribution of Nilakantha. In the earlier astronomical text, we just have the plan, how to compute the planetary position. This has been discussed, but what would have been the geometrical picture behind that was unclear until the Nilakantha. See here he says, Graha Brahmana Vrittani Gachanti Uchchagatinapi. The orbits also have motion. The locus of the path traced by Grahana Vritta is stated to be the Manda Vritta. See here, this UM is Ucha, the apogee of the planet, and the S is actually the sun. It is called Shigra. This epicycle also moves. In the case of the sun and moon, the earth is the center of the Mandavritta, and they move at the rate of Ucha. This is how he has described. This is a model he discusses. I will not go into the details of it. This needs much more time to discuss. So this is how Nilakantha has described this. We can call it as geoheliocentric picture or something like that. And so all these statements are very important in this discussion. So about the geometric picture of the planetary motion, I'll skip them. And see, he has revised the earlier model actually. So the first one is pre-Nilakantha model, and this is the post-Nilakantha model about the interior planets. It is based on some the computations described in the text. I will not go into the details of them. So he says, Aptavachanat Pratyaksha Parikshnirva Ayam Bhago Jneya, while introducing. See, Aptavachana literally means the words of reliable or trustworthy persons. As Professor was saying yesterday, the Agama is also important in having cognition. All these statements are very important in the scientific tradition also. The Pratyaksha Parikshana is based on the findings of observations, and some interesting statements he says makes. Vakshemanastu buddhimatam swayam nirupeva jnatum shakyam. Whereas the one thing is going to be explained can be understood by the intelligent ones by themselves. Tathapi shishyanam laghavaya tad dingmatram pradarshyate. Even then, in order to facilitate the students, we briefly outline the approach. And one of the things is the description of Bhuja Koti Karnanyaya, this so-called Pythagoras theorem. So this is the Kshetra Ksheda, cut and paste method. And finally he says, Etat sarvam yukti moolam eva, nat tvagama moolam. All these are based on reasoning alone and does not need the authority of any authentic text. ततः प्रतिभाजुषां चक्षुर्हस्तादिव्यापारं विना मनसा निरूप्य एव निर्णेतुं शक्यम्. Hence the intelligent ones will be able to convince themselves mentally without even employing their eyes, hands, etc. See, this is gives a message that we have to try and work out things mentally to the extent possible rather than trying to resort to the external means. And in the summary, he says, here he shows the spirit of a scientist. Ityetat sarvam dravyabhutasya purushasya avashyam spurati. All these become evident to any seriously thinking person. Why? Tasya samvedya sambandhi akila nyayavayavanam tattvajnana paryantam jijnasayah avishranti. Since his urge to know, the jijnasa, never subsides till he clearly understands all the principles involved in what he wants to know. This is a remark Nilakantha makes as a profound remark. Perhaps he has introduced it to drive the message among the student community that the urge to understand the fundamental principles thoroughly can never be allowed to subside, a hallmark that distinguishes a true scientist from others. So, this is the summary of that text, and I conclude my talk with this. Thank you.
I am not a student of Jyotisha, but we generally count stars and Tithi Nakshatra, etc. From my birth, I have been observing there are Adhika Masa. Sometimes the Ganesha Chaturthi comes in August last week or September, and sometimes the Durga Puja comes in September or October. But always the Makara Sankranti falls on 14, 15, 16th of January. So what is the reason? Even though there was an Adhika Masa, the Makara Sankranti falls on in particular 15, 1 or 2 days. 14, 15, 16, 3 days. I have never observed skipping these 3 days. So just, it's my curiosity. Can you answer?
Yes, this Adhika Masa, this lunar month, the Masa we observe is a lunar month. It is based on the movement of sun and moon. The sun's position and moon's position, both are important. For the Sankranti, only sun's position is important. So, Adhika Masa happens due to the difference between the lunar year and solar year. See, solar year consists of 365 point something days, and we have 354 points some days in lunar year, Chandra Varsha and Saura Varsha. So there we have 11 days difference in a year. So after 2-3 years, the gap increases to 30, more than 30 days. Then we introduce Adhika Masa. So the adjustment of lunar and solar calendar. Sankranti is purely based on sun's position. So it doesn't have something to do with the moon's position. So the Adhika Masa doesn't affect that. So on the background of stars, we observe the position of the position of the planets on the background of stars. So we draw a line from us, from the observer to the planet, and that line goes up to the star. So this is how we find the position of the planet. So planet-star conjunction. But since we are seeing from the Earth, sometimes we see that planet moves forward and comes back. Actually, it is not. Since from a point on the Earth, we observe like that. If it is a heliocentric thing, we don't have retrograde motion. So only from the Earth, when we observe, we perceive that planet moves forward and comes back at some portion of the ecliptic. Actually, it doesn't come back, but the line of observation when we make, so we feel that it is moving like that. So it is like two cars are moving, and sometimes we feel that one is going behind. Actually, it is not moving backward. Both are moving fast because of the speed, the variation in the speed. The other observer may feel that it is moving back. It's not because of the relative motion. We feel like that.
Thank you so much, sir. I wish to thank you for such an elaborate account on contribution to astronomy. There's a text called Panchadhyay, in which you mentioned that the source Siddhant was considered to be the most accurate one. Panchasiddhantiki, yes. So, which were the two positions which were considered to be least accurate ones? And the second question is related to Varahamihir.
Panchasiddhantika is a compilation of 5 texts, 5 Siddhantas.
Yes.
So I didn't say it is giving the accurate result. So among the 5, Varahamihira says Surya Siddhanta
is the most accurate one.
Most accurate.
Which are the least accurate? Two, you mentioned the two were least accurate.
So he says that Paulisha, Romaka and Saura, he mentions 3. And the other 2, Paitamaha and the other one, Brahma. So that is why he has created Brahma Sputa. Brahmagupta. Brahmagupta has made some correction to the Brahma Siddhanta, and he has.
Second question is related to Varahamihirji, whether he is associated with Qutub Minar, Mehroli.
I don't know.
The king at that time offered him the village named Mehroli, and from that Miravili. Thank you, sir. Thank you.